All right, part number 3. So what we were talking about was iron in the case of that hot dog fork. Why does it glow red? Well, what actually happens in that is if we do the electron configuration for iron, so iron has an atomic number of 6. That's 26. And that's all we're really going to worry about is the 26. Let me get black to show it better. So we got iron, atomic number is 26. There we go, now we can see it better. So we're going to do that Niels Bohr model. Looks like this. All right, we only need 1, 2, 3, 4. I know it's supposed to go all the way to 7, but we really just need 4. If I put all 26 electrons in there, they're going to go 2, 2, 6. There's 10, 2, 6, 2. That's 20. And then I drop down here, and I'm going to drop off 6 in that spot. That would be 26 electrons. Now, what ends up happening is, this is my outermost energy level out there. And what these electrons do is, as it heats, those electrons get really, really excited. And they're like, whoa, God. They're like really, really excited. And these electrons will jump down into here because they get so excited. They get so much energy, they jump up to a higher energy level that takes more energy to put them into. Well, then as they're sitting there, those electrons go, and they lose that energy. As they lose that energy, they'll jump back down. Well, if they lose that energy, that means that energy's got to come off. So we're going to get that energy given off. And it's given off in a specific frequency. And in the case of that iron hot dog fork, it gives off that frequency in the region of infrared, which gives us heat. And it gives it off in the frequency of reddish orange. Right in that region, we get red or orangish colors coming off. Right? If you're using copper, then it's going to be a different electron because copper has a different electron configuration. It's a different electron that jumps up. And then when it goes back down, it gives off a different frequency, and we see some heat again, but we also see some green color, which is a different frequency. And actually what scientists can do is they can look at things, and depending upon what color is emitted, can tell them what the substance is. And that's how we can look at stars that are millions of light years away that nobody's ever been to, and scientists can say, well, that star is made up of helium, it's got some sodium, it's got some potassium in it, got a little magnesium. How in the world do they know that? They've never been there. Well, they know it based upon the colors that are being emitted. We know it because we know that helium, sodium, magnesium, they emit these frequencies, and those are the frequencies that are coming off of that star. So therefore, we know those elements are present in that star, and that's how they can determine those. You also see in the movies like CSI type movies, they'll take something that they don't know, and sometimes they'll show that they stick it in something, they burn it, you see like the little particles come off, and they'll go, oh yeah, that's this stuff. Right? Well, how do they do that? Well, again, what they're doing is they're determining the frequency of the colors that are coming off as they burn a little bit of it, and based on that frequency, they can tell what that unknown substance is. So that's how they do. That's how they can utilize this idea of the atomic emission spectrum in order to determine things. All right, well, that actually finishes this set of notes, so we'll see you next time. Have a great day.